When we have a word problem and they ask you to look for the maximum or the minimum, that we need to find a maximum or minimum value, chances are we need to complete the square. Chances are going to be extremely good in the practice problems you're going to have, like 100% good that this is the process that you need to take. So here we have a baseball tossed straight up. Its height is a function of time. So its height is a function of time. I'm just going to highlight this for you. Height is a function of time. That's what the h of t means. H stands for height, a function of time. Time is our input. Okay? It's given by the formula h of t equals negative 16t squared plus 64t plus 6. H is our height in feet, and t is our time in seconds. What's the maximum height of the ball? When does it reach this height? So these are quadratic equations that mimic vertical motion problems. So they are vertical motion problems. We are going to, and you learned about these in Algebra 1 and in Algebra 2, we are going to take this quadratic and we are going to complete the square, because we know that the vertex gives us an input and then either a max or a min based on, I'm just going to make this the comma that it's really supposed to be. There we go. So you've got an input and a max or min based on whether or not our function opens up or if it opens down. In this case, because we have a negative a value, we have a quadratic function whose parabola is opening down. That gives us a maximum value. We want to know what is the maximum height and when does it reach that height. So this is going to be our max, the y value of our vertex, and this is going to be the when. That's going to be our time, okay? So our input is your time in seconds, right? And then your output is your height in feet. So let's get started on completing the square. We've got h of t equals, I'm going to factor out negative 16 from the variable terms. So I've got t squared. So we want to factor out that leading coefficient. When we factor out negative 16t squared plus 64t, when you factor out that negative 16, you're dividing it out. So I'm going to be left with t squared minus 64 divided by 16 is 4. And then I'm going to leave room to complete the square. Then I have plus 6 at the end. Okay. So I'm going to complete the square by saying half of 4 is 2. 2 squared is 4. Negative 16 times 4 is negative 64. So now I'm going to add 64 to zero out what we just did. So h of t is equal to negative 16 times t minus 2 quantity squared, that 2 comes right there, plus 70. So this is where what we did in our previous lessons are really important. What we did in our previous lessons in completing the square, this should be pretty darn smooth. So we have a vertex of 2, 70. That means that when time is 2 seconds, we reach a maximum, so a max height of, I'm going to move this over to the left here so I can just keep it all on one line here, a max height of 70 feet. So what is the maximum height of the ball? The max height equals 70 feet. And that happens after 2 seconds. So after the ball is tossed straight up, 2 seconds later, we will reach a maximum height of 70 feet, and then it begins falling back to the ground. Okay, here we have a try. Suppose that a baseball is tossed straight up and that its height is a function of time and is given by the formula h of t equals negative 5t squared plus 25t plus 8. This time, height is in meters, time is still in seconds. What is the maximum height of the ball, and when does it reach this height? Go ahead and press pause. Go ahead and press pause, and when you're ready to check your answer, you can press play. So if you're back to check your answer, here we are, spoiler alert, here's all of my work. So my input is time in seconds, my output is h of t, which is our height in meters off the ground. And you can see that I factor out the negative 5, half of 5, right here. So half of 5 is 5 halves, and then I square it, giving me 25 fourths, right? And then negative 5 times that 25 fourths is where this negative 125 over 4 comes from. To undo the negative 125 over 4, we add 125 over 4. I got a common denominator with my 8, which allowed me to take 32 plus 125, giving me 157 over 4. And I get a vertex of 2.5, comma, 39 and 1/4, which is also 39.25. That means that my maximum height is 39.25 meters, and that occurs after 2.5 seconds. 2.5 seconds after the ball is released, we reach a maximum height of 39.25 meters. So there's a great example, and hopefully you got the try. We'll get some more practice in there. There's lots of these types of problems that we can find that would give you practice, and we're going to find those in the homework. Our next video, we're going to talk about all rectangles having a perimeter of 20 feet. Which rectangle, what would be the dimensions of the one that has the greatest area? We're going to talk about that in the next video.